Welcome to Algebra 1, Unit 7, Lesson 4-2, Solving Inequalities Using Addition and Subtraction. Pearson Algebra 1, copyright 2009. I'm Mr. Pilarski, and our objective today is I will be able to solve inequalities with addition and subtraction. In reality, this is two objectives. We're going to look at solving inequalities with addition and solving them with a subtraction with two different properties we're going to learn about today. Let's talk about the first property. The first property is the addition property of inequality. It reads, for every real number a, b, and c, if a is greater than b, then a plus c is greater than b plus c. If a is less than b, then a plus c is less than b plus c. Let's take a look at what exactly is going on here. In this first little sentence, we're given the inequality a is greater than b. If we look at the second inequality, we still have the a and the b, but you can notice that c has been added to both sides. If we look at this inequality over here, what we start with is a less than b. And on the other inequality, we have a and b, both on the left and the right-hand side. And we have added c to both sides here. What this means, similar to the addition property of equality, it means to maintain the balance, you must add the same numbers to both sides of an inequality. In this case, with letters or variables, if you will, we've added c to both sides of the inequalities. This property also is true for greater than and equal to, or and greater than or less than or equal to. A real quick review, because we're going to be asked to graph solutions. This type of circle, a circle that's been colored in, is called a closed circle. And we use that when we're graphing inequalities that have greater than or equal to in it, or less than or equal to. The key component that lets you know to color in your circle is this equal sign. The equal sign means that the number that you find is the solution, or is a solution to the inequality. So the closed circle means that the number below that closed circle is included in the solution set. This circle, a circle that's not colored in, is called an open circle, and we will use that when we are graphing inequalities that have greater than or less than symbols in it, meaning that the number being plotted on the number line at this circle is not a part of the solution. So let's take a look at a couple examples. And example 1t, using the addition property of inequality. Solve the following and graph the solution. The solving is very similar to solving equations. We look at part A, p minus 4 is less than negative 9. The goal when solving equations or inequalities is to get the variable by itself on one of the sides of the inequality. In this case, it's p minus 4. So we need to get rid of the minus 4. To do that, we use the addition property of inequality, which states that we have to add 4 to both sides. When we add 4 to both sides, the minus 4 and the plus 4 go away because they're opposites, and that leaves us with p on the left of the inequality, I should say. So I write p is less than, and then I simplify the math over here. Negative 9 plus 4. Well, that gives a negative 5. So our solution reads p is less than negative 5. Well, to graph this, it's a pretty easy thing to do. You can see I have a number line set up right here, and there's only 3 numbers on it. The middle number is going to be the number we solved for, in this case, negative 5. If you're interested in putting numbers on the left and the right, it's a pretty easy thing to do. I usually just put one number smaller to the left. One number smaller than negative 5 is negative 6. And one number larger than negative 5 would be negative 4. Now we need to actually graph the inequality. Since it's a less than symbol, I'm going to use my open circle that I have right here. And I'm going to use my arrow to shade to the left because it's less than. All numbers less than 5 are the solution to this inequality. Don't know why it switched, but we'll fix it real quick. And this would be the graph. P is less than negative 5. This arrow here means that the solution is to the left of negative 5, or all the numbers less than negative 5. If you're doing this by hand, what you would do is you would draw this open circle and you would darken this side of your number line. And you'd make a big bold arrow over here. So that's what it would look like if you were doing it by hand. Let's take a look at part B. Part B, similar to part A in the fact that we have subtraction in it. It's different because we have decimal numbers, but the work is no different. In part B, since it's a minus 4.5 and we want to get the a by itself, we want to do the opposite of subtract 4.5, which is add 4.5 to each side. Remember, we add to each side because of the addition property of inequality. Simplifying the left side leaves us with a because minus 4.5 and plus 4.5 are opposites and become 0. I bring down the inequality and then I simplify the addition on the right-hand side. 14.2 plus 4.5 gives 18.7. So the solution here is a is less than 18.7. To even simplify making your number line a little bit more, all you really have to do is label the number that you solve for as the middle mark. So I'll label that 18.7. Since this is a less than symbol with no equal sign in it, I would use an open circle. And I would shade to the left because it's less than. Numbers to the left of 18.7 on a number line are the solution. So we'll color or bold in that left side of my number line. So here we've seen two examples of using the addition property of inequality to solve an inequality. Next is the subtraction property for inequality. For every real number a, b, and c, if a is greater than b, then a minus c is greater than b minus c. If a is less than b, then a minus c is less than b minus c. Like we just saw with the addition property of inequality, we have the inequality that we start with, in this case a greater than b. And you can see c has been subtracted from both sides and the inequality hasn't changed. Just like when you were solving equations with subtraction property, when you solve inequalities, whatever you do to one side, you have to do to the other side. So this property that looks very mathematical up here can be summarized as this. In other words, to maintain balance, you must subtract the same number from both sides of an inequality. And we're going to see that here in example 2t. I'm sorry, example 3t. Example 3t, using the subtraction property of inequality. Solve the following and graph the solution. In part A, we have c plus 4 is greater than 7. We have to get the c by itself, and right now it's being added to 4. So to get rid of that add 4, we use the subtraction property of inequality, and we subtract 4 from both sides. The 4's on the left are opposites and become 0. Therefore, they go away. So I bring down the c, I bring down my greater than symbol, and I do the math on this side. 7 take away 4. Well, that gives 3. So our solution is c is greater than 3. So we need to make our number line. Number line's already here. 3 in the middle, 4 to the right, 2 to the left. Remember, bare minimum, you got to at least label the 3. I'm going to use an open circle again because there's no equal sign, and I'm going to shade to the right because it's greater than. When I mean shade, I mean make the number line darker and thicker on the side that is the solution. And you can test your answer, if you'd like, by taking one of the numbers on the shaded side, like 4, and putting in it for C, 4 greater than 3. If it's true, then you solve the problem correctly, and if it's false, you solve the problem incorrectly. Moving on to part B here, x plus 7/9 is less than 14/15. Difference between A and B here is now that we have fractions. A lot of my students, when they see fractions, they shut down. I don't know how to do it. Well, in fact, you do. What you have to do is get rid of the 7/9. We get rid of the 7/9 by subtracting 7/9 from both sides. Now, the reason I'm subtracting 7/9 from both sides and not 14/15 is because the 7/9 is on the same side of the inequality. It's on the left side. So I'll subtract 7/9 from both sides. The 7/9 on the left cancel. So I bring the x down. I bring the less than symbol down. Now I need to do the math here. Doing the math here by hand requires you to find a common denominator. The least common denominator of 15 and 9 is 45. So I rewrite each fraction with a denominator of 45, and then I need to adjust the numerators. 15 times 3 gives 45, so 14 times 3 is going to give 42. 9 times 5 gives 45, so 7 times 5 will give 35. So these are the two fractions we actually have to subtract. 42 over 45 take away 35 over 45. 42 take away 35 is 7, and we leave the denominators the same in the answer. So our solution here is x is less than 7 over 45. Much like we've seen in part A, since there's no equal sign here, well, first let's label this. The middle point on our number line should be 7 over 45. And we'll use an open circle because there's no equal sign, and we'll need to shade to the left because it says less than. So there's our solution, and there we've done 4 examples, 2 using the addition property of inequality, and 2 using the subtraction property of inequality. Let's take a look at a problem-solving situation. Example 4T, real-world problem solving. In order to receive a B in your literature class, you must earn more than 350 points of reading credits. Last week you earned 120 points. This week you earned 90 points. How many more points must you earn to receive a B? First, let's highlight the question and define a variable. The actual question here, what we need to find is how many more points you must earn to receive a B. So defining a variable in this case, some teachers call these let statements. We're going to let x equal the number of points needed to earn a B. So that's the definition of our variable. That's what we need to find. Now in this particular problem, it's a part-to-whole relationship. There are 3 parts that make up the whole. Now identifying what are the parts and what is the whole is an essential part of this. So let's take a look at identifying the parts and the whole. In order to receive a B in your literature class, you must earn more than 350 points of reading credits. This 350, think about it. Is it a part of the whole or is it the whole itself? Hopefully you answered it's the whole. That's how many points you need to earn a B. This 120 points, this 90 points, are they the part or are they the whole? Last week you earned 120. This week you earned 90. It sure sounds like they're the parts. Now, there are only 2 of the 3 parts. The third part is how many more points you need to earn a B. So to write this equation, we're going to take the parts, add them together, and set it equal to the whole. But we're not going to use an equal sign. In fact, we're going to use an inequality. So to develop this equation, in essence, it's parts plus parts plus parts is equal to the whole. As I said, we're not going to be using an equal sign in our inequality, but for all intents and purposes, it's a part-to-whole relationship. 3 parts being added give us the whole. Now, the one part of the whole is how many more points you need to earn a B, plus the 120 points you earned last week, plus the 90 points you earned this week. And we're going to ultimately make that equal to 350. But we're not going to use an equal sign. We're going to use an inequality, and that inequality comes from this sentence starting right here. You must earn more than More than can be interpreted as greater than. The points you earn on the left has to be greater than how many points you need to get a B. So to solve this equation, first we have to add 120 and 90. 120 plus 90 gives 210. I bring down the x, I bring down the plus sign, that's this x and this plus sign. I bring down the greater than symbol, and I bring down the 350. Using the subtraction property, because this is an addition sign, I subtract 210 from each side. Two tens on the left go away because they're opposites. They become 0. And x is greater than, when I do this subtraction, 0 take away 0 is 0, 5 take away 1 is 4, and 3 take away 2 is 1. So x is greater than 140. Relating that back to how we defined x, you're going to need 140, you're going to need more than 140 points to earn a B in your literature class. This has been Mr. Pilarski with solving inequalities with addition and subtraction. Thanks for watching. Bye-bye.